everyone, this is Kalpana here. In this video, we are going to solve the given differential equation. So let's get going. Problem: solve dy by dx plus y cos x equals to y power n sin 2x. Solution: given differential equation. Dy by dx plus y cos x equals to y power n sin 2x. You can also write this as dy by dx plus function of x into y equals to function of x into y power n, which is a Bernoulli's equation, right? Or which is in Bernoulli's form. By comparing these two equations, we know that the Bernoulli's equation in y and x is of the form dy by dx plus p into y equals to q into y power n, where p and q are either functions of x alone or constants, and here n is a real number such that n not equals to 0 and n not equals to 1, right? So by comparing these two equations, we can say that the given equation is a Bernoulli's equation, and we can find P and Q by comparing these two equations. Okay, we'll just get P and Q, where P equals to cos x and Q equals to sin 2x, which are functions of x alone, since it involves only x and it does not involve any other variable other than x, right? So here P and Q are called as functions of x alone, and for a real number n, you can say that we are given a Bernoulli's equation in y and x, right? Now, we have to reduce the given equation to linear form. We know that the standard form of linear equation in y is dy by dx plus p into y equals to q, where p and q are either functions of x alone or constants. Now, compare this Bernoulli's equation with linear form. You'll have dy by dx plus function of x or a constant into y equals to function of x or a constant into y power n here, right? If you compare the RHS part, in the RHS part of linear equation, either you can have a function of x alone or a constant, but you won't have any y function in the standard form of linear equation y and x, right? So we don't have any y here, but here we are having a term in y. So what we have to do is, we'll simply eliminate this y power n from this equation in order to reduce Bernoulli's to linear form. So how you can eliminate y power n? Simply you can get this to LHS, or you can multiply both sides of the equation with 1 by y power n, or you can divide both sides of the equation with y power n. So let's see what happens if we bring y power n to LHS part. You'll get 1 by y power n. I'm writing directly now. 1 by y power n into dy by dx plus cos x into y by y power n equals to sin 2x. See here, y power n is eliminated, right? So now we'll see what happens exactly while multiplying LHS part with 1 by y power n. Okay, if we bring this to LHS part, you'll get 1 by y power n times the LHS part, that is dy by dx plus cos x into y equals to sin 2x right? Then you'll get 1 by y power n into dy by dx plus cos x into y by y power n equals to sin 2x. Okay, again you'll get the same thing. Fine. Now, what happens if we multiply both sides of the Bernoulli's equation with 1 by y power n? See, in RHS you'll have sin 2x into y power n in the Bernoulli's equation, right? We are just multiplying 1 by y power n to both sides of this equation. Then you'll get 1 by y power n into dy by dx plus cos x into y by y power n equals to, here y power n gets cancelled, and again you'll get sin 2x, the same thing. You'll get the same equation. Likewise, we can check for y power n. Simply divide the Bernoulli's equation with y power n. That is both sides of this equation with y power n. Then this becomes 1 by y power n into dy by dx plus cos x into, here you are having y by y power n, right? You can write y as y power 1. We know that reciprocal of y power n can be written as y power minus n, right? Then you can write this as, simply split this as y power 1 into 1 by y power n. Then you will get, or you can write this reciprocal of y power n as y power minus n. So here the bases are equal, so we can add the powers and we'll get y power 1 minus n. So you can replace y by y power n and y by y power n by y power 1 minus n. You'll get y power 1 minus n here equals to sin 2x. Now, let y power 1 minus n equals to some u. Let u equals to y power 1 minus n. Now differentiate on both sides, or differentiate this with respect to x. Here we'll use chain rule. Du by dx equals to du by, here we are having the function of y, so we'll get a differential dy in between. Now find, then du by dx equals to, find du by dy, that is u equals to y power 1 minus n. Differentiate on both sides with respect to y. Then you'll get du by dy equals to, derivative of y power 1 minus n with respect to y is 1 minus n into y power 1 minus n minus 1, right? Which is equals to 1 minus n into y power, here plus 1 minus 1 gets cancelled and you'll get y power minus 1. Again, you can write y power minus 1 as 1 by y power n, since y power minus n equals to reciprocal of y power n, then you'll get 1 minus n into 1 by y power n, right? Now replace du by derivative of u by derivative of y equals to 1 minus n into 1 by y power n. Now we can replace derivative of u with respect to y here. You'll get 1 minus n into 1 by y power n into dy by dx. Okay, so in books and in general, we'll be writing directly instead of doing this process. Okay, fine. Then you'll get du by dx equals to 1 minus n into 1 by y power n into dy by dx. Now if you notice the first term, we are having 1 by y power n into dy by dx, right? To get this, what we'll do is, we'll simply bring 1 minus n to LHS, then you'll get 1 by 1 minus n into du by dx equals to 1 by y power n into dy by dx. So when u equals to y power 1 minus n, then 1 by 1 minus n into du by dx equals to 1 by y power n into dy by dx. Okay, now this becomes, now we'll write the above equation in terms of u and x by replacing y power 1 minus n by u and 1 by y power n into dy by dx by 1 by 1 minus n into du by dx. Then the above equation becomes 1 by 1 minus n into du by dx plus cos x into u equals to sine 2x. Right? Now, we'll make the quotient of du by dx to 1. In order to make this to 1, what we have to do? We have to eliminate 1 minus n from the equation, right? From this first term, I can say. So what we'll do? We'll multiply both sides of the equation with 1 minus n. Okay. Let's see what happens if we multiply the above equation, that is both sides of the equation, with 1 minus n. Then you'll get 1 minus n into 1 by 1 minus n into du by dx plus cos x into u equals to 1 minus n into sine 2x. Then 1 minus n by 1 minus n into du by dx plus 1 minus n into cos x into u equals to 1 minus n into sine 2x. So 1 minus n gets cancelled from the first term. Then the reduced equation is du by dx plus 1 minus n into cos x into u equals to 1 minus n into sine 2x, which is linear equation in u and x. We know that the standard form of linear equation u and x is du by dx plus p into u equals to q, where p and q are either functions of x alone or constants, and integrating factor is e power integral p into dx, and general solution is given by u into e power, that is integrating factor equals to integral q into integrating factor into dx plus c. Okay. Now, by comparing this equation with the linear equation in u, we can say that we have reduced the given equation to linear form. That is, this is linear in u. Du by dx plus function of x into u equals to function of x, right? Since p and q are either functions of x or constant, but we have functions of x here, right? Which is linear in u, where p equals to 1 minus n into cos x and q equals to 1 minus n into sine 2x. Now we need to find the general solution. So the general solution of the given equation is given by the general solution of the reduced equation, that is standard form of linear equation in u, or linear equation in u simply. Okay. So the general solution of this equation will be the general solution to the given equation. So before finding general solution, we need to find integrating factor. Integrating factor equals to e power integral p dx. For p, 1 minus n into cos x into dx. Here 1 minus n is treated as constant, so let's take it outside the integral. E power 1 minus n into integral cos x dx. See, here n is a real number and 1 is also a number, right? So 1 minus n is treated as constant. This equals to e power 1 minus n into integral cos x is sin x. Here we will not write any constant here because e power some constant is also some number. Okay. Instead of writing plus constant for every integral, we'll finally write plus c in the general solution. That is enough. So we got integrating factor e power 1 minus n into sin x. Now we can find the general solution. General solution of the given equation is u into integrating factor e power 1 minus n into sin x equals to integral q for q equals to 1 minus n into sin 2x into integrating factor e power 1 minus n into sin x into dx plus c. Since we know that sin 2x equals to 2 sin x cos x, then RHS part becomes 1 minus n into 2 sin x into cos x into e power 1 minus n into sin x into dx plus c. Now write this constant 2 outside the integral. We get 2 integral 1 minus n into sin x into cos x into e power 1 minus n into sin x into dx plus c. Right? Let 1 minus n into sin x equals to some t. Now differentiate on both sides with respect to x. Here 1 minus n is constant. So we can write this as constant into derivative of sin x with respect to x equals to dt by dx. From this we'll get 1 minus n into derivative of sin x is cos x equals to dt by dx. Now bring this dx to LHS, you'll get 1 minus n into cos x dx equals to dt. Right? Since 1 minus n into sin x equals to t, then 1 minus n into cos x dx equals to dt. Then the integrand becomes, this becomes 2 into integral. You can just write this as see, you're having 1 minus n into cos x dx equals to dt, right? From this we'll get cos x dx equals to dt by 1 minus n, or cos x dx equals to 1 by 1 minus n into dt. Right? So now we can write the above integrand as 1 minus n into sin x into e power 1 minus n into sin x into the remaining cos x dx plus c. Now it is easy to replace 1 minus n into sin x by t and e power 1 minus sin x by t, and also You can replace cos x dx by 1 by 1 minus n into dt. Is equals to 2 integral t e power t into replace cos x dx by 1 by 1 minus n into dt. Okay. This becomes 2, right? 1 by 1 minus n, since 1 by 1 minus n is constant, so you can write it outside the integral, then you'll get 2 into 1 by 1 minus n into integral t e power t dt plus c. Since we know that integral x into e power x dx equals to e power x times x minus 1 plus integral constant c. If you want, I can prove this. Here the integrand is of product of polynomial function into exponential function, right? Consider polynomial function as u and the remaining part as dv. Then we'll get u equals to x and dv equals to e power x into dx. Here differentiate on both sides with respect to x. Then you'll get du by dx equals to derivative of x with respect to x is 1. From this we'll get du equals to dx, right? So here we'll integrate to find v. Then we'll get v equals to e power x. Now we can apply this formula. Integral u into dv equals to uv. U into v minus integral v into du. For du equals to dx. This is x. Then you'll get x e power x minus integral e power x dx is e power x. Now take e power x common from these two terms. You'll get e power x times x minus 1. Obviously we'll write plus integral constant. Okay. This one. Sometimes you may forget the formula. Then you can use this integration by parts to recall the formula. Okay. Now this becomes 2 by 1 minus n into e power t for x equals to t, right? You'll get e power t times t minus 1 plus integral constant c. Now replace t, since t equals to 1 minus n into sine x. Then this becomes e power 1 minus n into sine x into t. 1 minus n into sine x minus 1 plus integral constant c. The LCM of these two terms, you'll get 2 e power 1 minus n into sine x into 1 minus n sine x minus 1. Here 1 minus n is the LCM, right? Plus the numerator will get 2 into this part plus c into 1 minus n. Fine. Okay. Then u into e power 1 minus n into sine x equals to 2 e power 1 minus n into sine x into 1 minus n into sine x minus 1 plus c times 1 minus n by 1 minus n. Now take this 1 minus n to LHS and bring this e power 1 minus n sin x to RHS, you'll get u into 1 minus n equals to 2 e power 1 minus n sin x into 1 minus n sin x minus 1 plus c into 1 minus n by e power 1 minus n into sin x. So in the numerator of RHS, you're having two terms, 1 and 2, and in the denominator, you're having one term. So we can split the total expression into two terms. You'll get 2 e power 1 minus n into sin x into 1 minus n into sin x minus 1 by e power 1 minus n into sin x plus c into 1 minus n by e power 1 minus n into sin x. So here e power 1 minus n sin x gets cancelled from the first term of RHS. Then you'll get u into 1 minus n equals to 2 times 1 minus n into sin x minus 1 plus, we can again split this as c into 1 minus n into 1 by e power 1 minus n into sin x. Then u into 1 minus n equals to 2 times 1 minus n sin x minus 1 plus c into 1 minus n into reciprocal of e power 1 minus n sin x is e power minus of 1 minus n sin x. Right? This is equals to 2 times 1 minus n into sin x minus 1 plus c times 1 minus n into e power. Take this minus inside the brackets. See, you're having minus of 1 minus n can be written as minus into 1 minus 1 minus into minus plus n. So you'll get n minus 1, right? So you can replace minus of 1 minus n by n minus 1 into sin x. Okay. Now let's replace u. Since u equals to y power 1 minus n, then the above equation becomes 1 minus n into y power 1 minus n equals to 2 times 1 minus n sin x minus 1 plus c into 1 minus n into e power n minus 1 sin x, which is a required solution. So we have seen a problem from Bernoulli's equation in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.